Hello, everybody. Welcome again to Beyond Kicking and Punching with Sifu Aldecascos. Everybody, big hand, big hand. I'm
Oh
so
yeah. Hey guys, I like that when you guys start clapping for me because we're gonna have a lot of fun today. Well, fun, but also being very serious about the topic that we're going to be talking about. Beyond kicking and punching gets beyond kicking and punching, and we've had a lot of people come on and talk about various subjects, but I've never had somebody that is so interesting talking about a subject that concerns us all, everybody around the world, and he's done a lot of things. First of all, let me say that he's been a student of what I've been teaching in the martial arts for some past 40 years or so. And he's I remember when he had a little bit more darker hair on his head and a little bit more slimmer. And some 45 years ago when we were in Portland, Oregon, he continued his training and went on to get into medicine and the science of airborne pandemic viruses and whatever you call that. I'm saying this because I'm coming from a layman's point of view. I'm very naive about it. So I need to know a lot of things that's what's actually going on. And I'm sure a lot of you have a lot of questions too, which we're going to open it up to a couple of questions that you folks may have at the ending. But let me just say that I'll give you a little bit of background. It's just that Jeff, Dr. Jeff Cirillo, I mean, it's really odd because I used to just call him Jeff, but now it's Dr. and Professor Cirillo.
Still Jeff, still just fine.
No, you're a doctor, you earned the title and you're a professor in the science. And let me see, he's ended up with a lot of awards. It's so going back to 1983. And if I were to just talk about every single awards and magazines or televisions that he's been on, it probably would go from one end to the other hand and take up so much space. But I'm going to, let him talk about it more because it's about him. It's about what's happening in the world today. It's about what's going on with the pandemic and questions on fake news, real news, and so forth, because there's so much questions that people have. But being that he's been in this subject for over 30 years, us laymen, or some of you who are interested in the subject or have any kind of medical background, I mean, it's going to be interesting to you to hear from another point of view. And believe me, it's going to be really interesting. Jeff is also at Texas A&M Health Science Center, College of Medicine, and he runs the Department of Microbial Pathogenics and Immunology. He also went to Stanford University of Medicine. His education goes into so much that most of us are still in kindergarten when we talk about the knowledge he's gained. And being that he knows all of this, it's like in the martial arts, I was the person that was grabbing him by the hand and leading him. Now it's the other way around. He's at the front end leading me and a lot of other people to find out what the truth is between what is going on in the world today. So I'm going to turn it over to Jeff. Jeff, I'm going to, I guess, first of all, let's welcome Jeff onto the show. Jeff, welcome to the show. All right, great. All right, Jeff. Question, so much things is there going on that I want to know, we've got so many variants going on. How do people know what the variants are? I mean, if you have one that went into the other, tell me, how does variants go from, the Delta variants and so forth? I mean, would you enlighten us about it and why? Because I'm going to hit you on a lot of things, but first of all, I want to know about these Delta variants.
Well, if you didn't hit me, I feel like something was wrong.
Right.
That's how we started out. So yeah, I mean, it has been many years, and it's just a pleasure to have the opportunity to be here today. Thank you for giving me the chance to talk to people a little bit more about my work. I I usually keep my work very separate from my martial arts. It's kind of funny to see the perspective of different people in both of those arenas. They're very different. So as professors and faculty in the university and as a martial artist, they sometimes don't understand. So I think also there's cases where martial artists don't understand some of the things going on in the scientific community and with medicine and health. And there's really not a conflict. There always seems like there's a conflict, but variance, I think oftentimes the biggest problem with that term is that people are trying to be kind of scared of it. So it's associated with fear. The differences between the variants that we have so far, including the Delta variant and the variants that have already been in existence, are not that great. It's not a completely new virus. And I've had people ask me that. They gave it a name. They call it Delta variant, it's Alpha variant. There's other variants out there, and they come from different regions. There's the Brazil variant, the India variant, the Russia variant. We even have a Texas A&M variant, which is specific to the university. But they're all defined by sequence. So that's how we determine whether or not something is a variant. And we look at the complete sequence. That's another kind of misconception, is that people think we don't understand the virus. We do. We know pretty much everything about the virus at this point. The genome has been sequenced thousands of times, and thousands of different versions of it are available publicly. You can actually access all this sequence yourself to follow it. This issue comes up when people talk about the origins of the virus, and they try to say it came from a lab. It's very obvious by the sequence that it couldn't have come from a lab. That was proven in the very beginning by the sequence. And so people say, well, you didn't investigate it. And we all said, well, the sequence proves that it isn't man-made. And it's because people don't understand how we can tell by whether or not something's man-made. And I think in the martial arts, a good analogy is mechanical versus reflexive. Reflexive is hard to reproduce. You have to train it, you have to learn it. Evolution works in a reflexive manner. It's very smooth, very clean. It's very, very difficult to reproduce. Even with all the technology, we got lots of technology, and some of the things we can do is pretty cool. But we can't fake stuff. It's really, really hard to fake stuff completely. There's always traces. It's like putting a copyright on a photo or a video. It can be traced. So that shows very clearly that there are variants in the virus, that the virus originated in bats is 100% clear. Did it have an intermediate host before humans? In other words, did it go through a palanquin or something, other types of species that could have been in the middle? But looking at Wuhan, it's pretty obvious that Wuhan, I'm not sure if everybody's aware, and actually some martial artists may be more aware of this than some of the scientists, that in Wuhan, bat soup is a delicacy. It's a very popular dish, and I spent a lot of time in China, so I know very well what the Wuhan market looks like, and it's got bats everywhere. So the idea that it even needed an intermediate host, to me, seems unnecessary. I mean, it is conceivable, but considering how many bats are in Wuhan, in that market where the infection started, it seems pretty obvious that sooner or later we're going to get a virus that can infect people. And that's because variants arise naturally. So variants are basically just different versions, like I'm a different version than Sunny. Our One-Up Kwun-Do is a little bit different, right? So it evolves over time. The virus changes over time, and the sequence changes. And so when the sequence changes, we call it a variant. It has to change enough to be a little bit different. In other words, to be my flavor of One-Up Kwun-Do, it has to have my style in it. So the variants are like that. The vaccines currently work against all the variants. Is it conceivable that a variant could arise that could avoid the vaccines, or the vaccines wouldn't be as effective against? Yes, it's conceivable. The longer the pandemic goes on, the more likely that is to happen. That's my biggest concern right now, is that we need to go through another round of developing new vaccines. That's an extremely difficult thing to do. It's very expensive. It's very scary. So having avoidance would result in death. More people would die, but we don't have avoidance yet. So in other words, none of the variants yet have overcome the vaccines. And that's all of the vaccines. So all of the vaccines are effective against the variants. And people, I see this in the news every single day, somebody saying something about how this vaccine doesn't work as well against the variants as that one. All of that information has come out for basically every single vaccine, and it's all been proven false. So and the reasons for that are mostly because the antibodies that are involved in protection from the virus. So when the vaccine is effective in an individual, it produces a good response that's effective, which these vaccines are very, very effective. They produce a response that's like 100 to 1,000 times that seen by somebody who's even infected. And so this is one of the misconceptions, right? They say, oh, I got infected already, I'm protected. No. Many times people that have been positive before don't develop as strong a response as the vaccine, because the vaccines are designed to produce that specific response. And the one thing we know about coronaviruses, which is a type of coronavirus, is that if the response is not specific, you're not protected well. And not only are you not protected, it can be worse. In other words, so if you think of this as the epitope, so the binding site that binds the virus to us, right? So it binds to us. That surface is all you need to protect against, right? So we get antibodies that bind that surface with the vaccine. That's how they're designed. They're designed specifically to get an antibody to bind that. So they bind super tight. The tighter they bind, the better. And that prevents it from binding to the cell. And it can't infect it, right? Can't hurt it at all. So what happens though, if you bind here, and that happens all the time, we get antibodies that bind to this because we got infected, or we had an asymptomatic and you didn't get very sick, so you didn't get a very strong response. People think, oh, I didn't get very sick, so I'm good. Now that's actually a bad thing, because those antibodies oftentimes are not specific and they're binding all over, and I can still get the virus attached to the cell. So that's not good. And not only that, there's something called antibody-mediated exacerbation. So where the antibodies that are not specific, they actually allow the virus to get into the cell by, there's a site on the antibody, you can put it at my elbow, it's called the FC site. That site allows an antibody to pull something into the cell. It's one of the ways that protects us from most things. But in the case of coronaviruses, it can enhance their uptake, so it can increase their uptake. So in the case of vaccines, it's very specific response, but in the case of other types of things, you get a non-specific response and you can sometimes get even worse disease. So that we want to be really careful for, and any avoidance we need to design specific vaccines for. But yeah, so that's the variants. They will continue to arise. I'd say stay calm until you see what happens with it. In other words, I always watch. I'm always careful. Nobody in my family's been infected. My parents haven't been infected. And it's all because we follow very specific practices. And I can go through those. I mean, to me, they're kind of common sense, because that's what we do every day. We work with respiratory infections. And there, in the laboratory, there's levels. There's biosafety level 1, 2, 3, and 4. We work at level 3. And tuberculosis is a level 3 pathogen, which means it can kill you. Coronavirus normally is a BL1 or BL2. This coronavirus, so SARS, we call it SARS-2, SARS-CoV-2. This virus is a BL3 right now. So it would be worked with in my lab. So we work at a very high level of containment. We follow very specific practices, and we set up what are called barriers. A barrier from one area to another. As we change barriers, we have to take off clothing, do a decontamination process, and then we can come out and we're clean. And then when we go back in, we go through a reverse process. So right now I'm treating the entire world like a BL3 lab. And even my kids, I've got a 6-year-old kid, he licks everything. So, but he's funny. I mean, we were just on the street the other day, and he sees a person without a mask, and he's like, "They're not wearing a mask." He comes running over to me, and I'm like, "Good job, good job." You at least told them they weren't wearing a mask. They probably should have been wearing a mask. And it's a kind of close quarter area, right? You probably don't need to wear a mask where you have space outside, but where you're starting to get close, you need to think about, okay, can I be breathing somebody else's breath? If I'm breathing somebody else's breath, I need to wear a mask. And so that's what we do. Is the kids, they're actually worse than me. The 6-year-old won't take his off. I can't get him to take his mask off. Yeah. So, you follow the practices, I think you're okay. They all apply to all the variants, even the Delta variant, which is more infectious. It seems to be infecting more people more easily. Probably that's because of stability. In other words, it's more stable. It doesn't break down as well in air. It can transmit more easily from person to person. So people who are not vaccinated, many of them that have been fine following whatever practices they're following up to this point. And some people, I talked to a convenience store clerk the other day. She said, "Oh, I'm fine. I deal with people every day and I haven't gotten the virus." And I'm like, yeah, well, this is when we're seeing people like you get infected. And so I don't know if you guys have been following the curves, which is what I follow, is decreasing cases and plateaus and decreases. And so what we're really looking for, we're looking for the decreases in cases to get down in the US to down to like 100 a day, something like that. It's not the end of the world at that point. It's kind of controlled, but we're still up around 20,000 per day. That's not full control. So we need to get to that point before I'll feel more comfortable.
Do you think that the main media is really hyping this up on the Delta variant?
Yeah, I mean, fear sells much better than calm does. I think they get interest and they get a lot of viewers out of it. So you kind of have to weigh what they say with the data. I actually don't watch any news. That works really well for me. I like Twitter because I can follow certain people, and that way I can filter out the people that I don't want to listen to because they're full of it. You end up with a set of people like the CDC or the World Health Organization or well-respected scientists or medical people, even doctors. I have had to deal with medical doctors that are telling their patients, "Don't get that vaccine." And I'm like, are you crazy? That is negligence. Okay, without a doubt. Telling somebody not to get the vaccine right now is negligence. If you're a scientist or a medical practitioner, and it doesn't even matter which version of the vaccine they get, all of these vaccines have shown the safety efficacy profile that is compatible with use, and much better. The frequency of side effects or severe problems due to the vaccines are 1,000-fold lower than the frequency of side effects due to COVID-19. So the concept that you would risk somebody's life by telling them not to get a vaccine right now, I think there's going to be a lot of lawsuits. Yeah. I don't know if you saw recently, one of the interesting lawsuits that's come out is one of the cruise line, I think Norwegian, is suing the state of Florida because the state of Florida put a mandate that no organization can require masks. And it's a cruise line. Of course, they're going to be wearing masks on a cruise ship. That's like a death ship if you're not wearing masks right now. So, and we've seen how many cruise ships get problems. So the evidence in support of Norwegian Cruise Line to sue the state of Florida, I think, is overwhelming. Hopefully they get a lot of money out of the state of Florida because that's a really stupid thing to do. But anyway, these are some of the things we're going to be seeing coming out. I expect a lot of these people that are giving false information are going to end up getting sued, and some of them are going to end up going to be in jail because they killed somebody. They gave somebody bad advice and then they died. Yeah, that's negligence.
In our news yesterday, we had a family, pretty much a complete family. Father, mother, cousin died within 2 weeks because they didn't take the COVID. And one of them now is still in the hospital. In ventilation. And having all of that. So it's pretty heavy. But then I hear people talking about that the Pfizer vaccine has that what they call the graphonin oxidant. I don't know, I can't even pronounce that, and that is supposed to be harmful and poisonous, and that because you got this metal over here, it has something to do with G5. You know anything about that?
So, I keep hearing these things about the ways the vaccines are made, and it comes out of a lack of understanding about the process. So a lot of commercial processes, you look at mango juice or coconut, milk or coconut cream. The processes it goes through and things that are present in the machines themselves that are not actually in the food are not a problem. And that's how we inspect our food. All of our food, all of our medicine, the levels of scrutiny that our medicines go through are probably 100 times that. So pharmaceutical, that's why we have pharmacists, right? You can't get a vaccine from your brother. You can't just, go say, hey, can you give me a shot? Yeah, that doesn't happen. And we're doing a clinical trial right now, just as an example, right? We're doing injections in people and thousands of people, but nobody can touch the pharmaceutical except the pharmacist. Nobody. Is not even me. I can't touch it. I can't even know where it goes. It's held there's so what is this chain of custody. It goes through a chain of custody that is documented at every single. So when the vaccines were initially approved, the process was checked, the formulation was checked, and the formulation can't be changed. So what the Pfizer vaccine is made out of, and that's kind of a secondary story, but it's mRNA, okay, inside what is called, we call them nanoparticles. Now, people are scared of that term right now. I don't know why, because what nanoparticle means, so there's sizes, right? A millimeter, a centimeter, a foot, a yard, right? Nanometer is a measurement. So when something's a nanoparticle, that just means it's that big. So I have many different types of nanoparticles. Soap makes nanoparticles, right? Whenever you wash your dishes, you're making nanoparticles. So the concept that the nanoparticles are scary, it came out of science fiction and movies. I know where it came from. We all know where it came from, but there's nothing in it. The nanoparticles that are used in the Pfizer vaccine are lipids, and they do have complicated names. They're glycosylated lipids, and what they do is so basically it's fat. You take these oils, you can actually make them, the nanoparticles, in your kitchen out of food. We usually use components that you would eat because those are not toxic. And so almost all vaccines are given that way, are given in some sort of formulation that is what we call inert. In the case of these vaccines, they're nanoparticles of fat. They have some sugar in them that helps to modify them. And the reason we modify the lipids is because we look to see so it's just like the virus, right? If you want to vaccinate against the virus, right, you've got to get something binding. It's binding to the cell, right? In the case of the vaccine, it's inside a little nanoparticle, which is basically the same size as the virus. And instead of it doesn't have the binding site. The virus has the binding site on top of it. The mRNA codes for the binding site. That's how the vaccine works, that mRNA on the inside of the lipid thing. And what these are is they're inverted lipids. So you take fat in solution, and then you add the mRNA, and the mRNA is actually charged. It has a negative charge to it. So it has a little bit of charge. It's ionic. It's like salt. It has a charge to it. So the fat binds to the RNA, and it makes a coat. That's your nanoparticle. That's it. That's all there is to it. The nice thing about that lipid, what they found is the mRNA, then when it goes to use that lipid, it merges and gets released into the cell, because it's kind of complicated. Fats have these kind of charge on one side and they're not charged on the other side. So when they bind to a cell, they open up and they actually will merge with the cell. The fat becomes part of the cell and it gets degraded over time because your cell already has all those fats in it already. And the mRNA gets released into your cell. And that mRNA then gets expressed and after it's expressed, it gets degraded. The mRNA probably lasts about 2 hours. It may last in terms of your entire system because they put in a specific concentration as long as a week. But we've never seen any mRNA that far out. Usually one day you can find a little bit, but after that we don't find it. It's at such low concentrations you don't find it. So that's all there is in it. The Pfizer vaccine is virtually identical to the Moderna vaccine. So the concept that there's something poisonous in the Pfizer and over the Moderna is completely false. Honestly, Moderna should sue Pfizer. The vaccines are too similar, and there's probably some patent infringement because Moderna had patent first. But the reason you're hearing these negative things about Pfizer, if I was to try to guess, so I'm going to call it a guess, why is people don't like Pfizer. And there's a lot of reasons to not like Pfizer. They're a big company, a really big company. And so they've kind of taken advantage of the opportunity to jump in on somebody else's technology, which Moderna has been working on this technology for many years. And so they have produced it, but they use a kind of a very commercial process to produce it in high scale. And I think that's what scared people, is because they're using these kind of like large factories for production. People have gotten concerned about some of the components that are in the factories, but they're not in the vaccine. Every single lot is tested very carefully. And so when you hear that word lot, a lot of people don't really understand it. It's like a pitcher, you're pouring some tea. When you make up tea once, you pour the tea. In the case of vaccines, it's all poured into the same cups right at the exact same time out of the same vat. So they are identical. Every single vial from that lot is identical, and every single lot is tested. Can you imagine what would happen to Pfizer if they had a problem with their vaccine right now? That would be it. They'd be done. And not just for the vaccine, they'd be done as a pharmaceutical company. That's happened to a few people when they've made mistakes in terms of production of pharmaceuticals. It's a big issue.
So talking about 5G, so 5G really has nothing to do with it?
No. I'm not sure how that, actually, I do know how that started. It started with some of the people that are out there spreading a lot of lies. And the question is, well, I know, at least in the beginning, a lot of it was political, right? So they suspended reality and they started to just make things up. And then they kind of headed down that path and they kept making it up. It's like somebody who goes out and says, I'm a black belt in this, or, once they get going, they have to stick with it. And at some point or another, sometimes they believe their own lies. That's when it gets really scary to me, right? I've seen these people, both in the martial arts community, as well as in science and medicine. I would have liked to see the guy that said, oh yeah, you should put Clorox in your lungs, inject in your lungs. I'd like to see him actually take his own medicine.
There's some talk.
So the 5G thing is like that. That's a paranoia. And I think kind of when it says, oh, 3G, 4G, 5G, I don't know about you, but I'm like, I'll wait, see how the 5G goes. I'm not getting a cell phone that's 5G right now. I'm not heading that route yet. But that's new technology. I don't think it has anything to do with the vaccines. I have not seen any evidence for anything related to any of the companies either. I think Pfizer's got enough to deal with and Moderna's got enough to deal with rather than trying to deal with T-Mobile.
I hear sometimes people talking about vitamin C, magnesium, and selenium, taking heavy dosage of that, and whether you take the vaccine or not, that thing should help you. Give me what's your take on that?
So vitamin C is the least innocuous of those. So in other words, it's the least detrimental. You can take a lot of vitamin C, but I don't know if any of you followed Jonas Salk. He's a very famous scientist, medical person, developed some of the vaccines and had his own institute in California. He swore that vitamin C cured cancer if you took mega doses. And so he's one of the ones that really put, and he won a Nobel Prize. So a lot of people listen to him, but he's one of the ones that said it. And he did it. He took the mega doses of vitamin C every single day. And these were crazy doses. I mean, 1,000 milligrams is a lot more than you need in a day. It's like 10 times your recommended daily dose. But he took more than that. He took like 10,000 milligrams per day. He died from cancer. So, it's kind of a lesson that vitamin C is really good. You need some. So all vitamins and cofactors. So selenium, what was magnesium? Yeah, it was the other one you said. You didn't say zinc, but I think zinc could be thrown in the same category. A lot of people think zinc megadoses are smart too. They're cofactors, okay? So cofactors mean, okay, I'll distract this guy, you stab him in the back. The cofactor stabs him in the back. You need that extra help. So vitamins are cofactors. They don't do the main work, but they do important work. They're absolutely required to get the job done. And so you need some, but you don't need a lot of them. You don't need 3 cofactors to get that one reaction done. You don't need 10 people to stab the guy in the back. You need 1. So it's not that complicated to realize, okay, once I get over a certain amount, that vitamin, which is vitamin C, selenium, zinc, magnesium, it's not doing anything, okay? Now, by themselves, and the reason, this is where the magnesium thing came from and selenium came from, is that if you use selenium and magnesium, they kill bacteria, they kill infectious agents. So, but I see this all the time with nutrition stuff. People will say, oh, if you eat this or if you eat that, it kills that or it cures cancer. A lot of times people are trying to cure cancer by these things. When you look at the actual paper and they show this kills cancer, you see they did it in a test tube. It doesn't work, right? Because that's not your body. If you add salt to a test tube, it'll kill pretty much any infectious agent. If you add salt to a test tube, it'll kill cancer. So that's not how they work. In your body, it has to, in order to have a role or to give you benefit, it has to reach high concentration. And that's where the megadose idea comes from. They say, but that concentration is so high, it's hard on your kidney, okay? Your kidney can handle only so much salt, okay? Which metals are salts. They're positively charged, unlike sodium. So selenium, magnesium, zinc, positively charged. Vitamin C doesn't have much charge to it, so, and it's a cofactor, so it's a ringed molecule. It gets broken down partly by your liver, so you can handle more vitamin C than you could handle selenium, zinc, and magnesium. But as you push those levels super high, now the vitamin C, it comes out in your urine. Your pee will change color, but that's about it. So you hit really high dose vitamin C, it's not going to kill you. But magnesium, zinc, and selenium can kill you. So you reach super high, you don't have enough water. That's what it comes down to. Your body has too much salt in it, not enough water, and you can die. So overdosing on magnesium, selenium, and zinc is a bad idea. I would stick with no more than the recommended daily allowances. If you say had a cold, the cofactors are more required. So if you're under a lot of stress, and that's where the zinc and selenium came from, is they're in those kind of throat lozenges. When you have a cold, you can take it, and that's a coronavirus, right? The cofactors that are involved in your response to those viruses use a little bit more. So the amount you should probably take would be 150% of your recommended daily allowances to 200. No big deal. But don't go the thousands. Yeah, that's not good for you. That's really not good for your body. And you want to have kidney failure. I don't know. You want to be on dialysis the rest of your life. I think that's a little bit worse than having a cold. Probably worse than having COVID. And too high levels also hard on your liver. So if you drink alcohol, which many people do, your liver's already stressed, and you add these metals in there and high levels of vitamin C, you're stressing your liver. So you can go into liver failure sooner in life, which would be a bad idea. Your body has kind of clocks in it. Your kidneys are on a clock, your liver's on a clock. So you don't want to do stuff that overstresses your body. It's really hard on it.
So I know this thing is spreading a lot. And you hear a lot of the virus spreading out in California and New York and things like that. What do you think contributes to that?
Well, so it's basically 100% of hospitalization. So people who have COVID or documented COVID right now, they're non-vaccinated. So it's a pretty simple map right now. People who are vaccinated, like I had a friend, he's another scientist. He's pretty sure he had COVID, but he's vaccinated. He didn't even go get tested. He's like, I had a cold for a couple of days. I was fine. My daughter got it, and they were all vaccinated. And see, my entire family is vaccinated down to my 6-year-old. So I'm ready to go out. And the only way I can, and they're only vaccinating down to 12 years old. And so I was pretty upset about that. I was like, they need to do trials in younger kids. So I found a trial for them. So I got them vaccinated. And so now we can go out. I'm not worried about infecting the young kids. The death rate in young kids is 1 in 50,000. So, I'm like, that's pretty reasonable. I don't think my kids would be in the 50,000, the 1 in the 50,000, but they might be. And so that's why I got them vaccinated. But anyway, yeah. So the entire COVID cases right now, all of the spread of the virus right now is in non-vaccinated individuals. Currently, there is not a documented case of spread from a vaccinated individual to a non-vaccinated individual. We see many, we see like a cluster, like my friend, his family got the virus all at the same time. You say, oh, well, he gave it to his kid or whatever. But no, they all got infected at the same time. So there was probably a source that infected them. They didn't infect each other. And the reason that's probably the case is because the antibodies that I told you about, if you're vaccinated, they bind the virus very quickly. So the virus is not at high levels. You produce so little virus when you're vaccinated, and it doesn't have time. So it's really unlikely that somebody that's vaccinated could spread the virus.
So you think that people that get vaccinated will probably have to have a booster also?
Yeah, I think that's very likely. When this all started, so we did an analysis of the protein, that spike protein. We know everything about that protein that you could possibly know, and everybody's studying it in excruciating detail. But what made it scary for me in the very beginning, before the vaccines came out, is that protein is a little unusual. It looks like HIV. HIV has a protein on its surface for the same thing. A lot of these viruses use a protein to bind to cells. And HIV, so the AIDS virus, right? There's no vaccine. And this has been out since the 80s, that we knew what caused AIDS. We knew the virus, we knew the protein. And I was talking to the people that are heavily involved in vaccine development for HIV, and they said, yeah, the protein for binding to the cells, called the spike protein. That protein is very similar between coronaviruses and HIV, and they have the same kind of characteristics. So the surface structure of it is such that it's not the same sequence. It's a very different sequence. So they're not the same virus at all, but the protein has that similar characteristic where it's designed to be able to avoid our immune response. And that's not good. That means that it's very, very difficult to make good binding antibodies to bind here. We get lots of antibodies to bind to, and we probably already have them because we have the common cold all the time, but we need those specific ones to prevent the disease. Those were difficult to produce. And so over time, as the number of these goes down, we have what are called memory cells, and they remember that we saw this before. We saw it, so we're going to produce antibodies quicker. So we do. But as those numbers go down, you're more and more likely to get a little more sick from the virus. In other words, it can infect you still. So the memory cells then have to survive. But your body's doing other things. You're exposed to the flu, you're exposed to other things. And so your body controls how much it does, and it reduces other things. And because this one is so hard to respond to, over time we lose that protection. So I predicted it wouldn't last more than 3 months when they got a vaccine. But the Moderna and Pfizer both were far beyond my expectations. So we look at the antibodies in particular. That's one of the things I work on. That's my primary role in our large clinical trial. And I've been working with antibodies for many, many years. I was amazed at the response, the quality of response, the strength of the response, the amount of antibodies produced. I did not, well, I guess I've had one. I have a I can't really say who he is. Anyway, one subject that is a correction officer in a jail. And as you probably are aware, jails have gotten a lot of COVID, because it's very close quarters and they're getting infected frequently and they're not necessarily careful about what they're doing. And so anyway, he's a correction officer. He had huge antibody levels, similar to vaccine. So one subject that I had one dental hygienist who had super high levels of antibodies. But that's it. And I'm talking thousands of people. We have probably at least 10,000 samples in my lab. So 2 infected had levels similar to the vaccine, but all of the vaccines, the ones that are vaccinated, the levels of antibody are through the roof. It's unbelievable. So it's really good. So we don't know how long it's going to last yet. But what we'll do, and what I will do, is I'll keep taking blood from myself because I'm vaccinated, my kids, everybody, all my subjects. We're following all our subjects for 3 years. So we'll know what happens with the antibody response. One of the other things we're studying is brain effects. So we know COVID affects your brain and can cause permanent damage in your brain, higher frequencies of Alzheimer's and Parkinson's disease if you've had COVID. So we're going to be following all these subjects to see how bad it is. We're doing brain imaging. We're doing cognitive testing to see how they manage memory, because I've seen with several of our COVID positive people, they lose memory. Memory seems to be the first thing to go in with COVID infection, which is not good. So we don't know yet how bad it is for that, and we don't know how long-term the response is. But so far, for at least Pfizer and Moderna, we have a lot of data. For the Janssen vaccine, we don't have as much data yet. It looks like it lasts at least 6 months. The Novartis vaccine looks like it lasts about 6 months at least. So more than 3 months, which is my original prediction. I was wrong. And so that's fine. I don't want to be vaccinated too often either, but we are doing trials right now on revaccination. So boosters, there's some big trials going on with that. So far, nobody who's been revaccinated has seen higher side effects than the original vaccine. And we're talking the second shot. So Pfizer and Moderna, right? You know that you get more sick after the second shot. Most people. Some people get sick on the first shot. I'm not quite sure why, but most people get a little more sick after the second shot. The booster looks like the second shot so far.
Right.
You get a little bit sick, not fun, but we aren't seeing anything major, which is great, which means we're not getting more anaphylaxis, which is what you're afraid of, right? You're like, you get a bee sting, right? Later you get another bee sting, you could die. Well, if you have anaphylaxis with a vaccine that is for some sort of allergic reaction, we worry that your next reaction will be stronger, and we're not seeing that yet. So far, and that's in thousands of individuals, maybe even 10,000 now, we haven't seen any higher side effects. So that's good. That means that the boosters are great, and it'll be just like having the flu vaccine every year. Hopefully it'll be yearly, but at this point, I'm planning on 6-month boosters. Myself, I had the Janssen vaccine. My wife had the Janssen. My kids, I have two kids that had Pfizer and 2 that had Moderna. And so we're going to just be checking antibody levels. When your antibody levels drop, that's when you should be boosted.
Good. I'm going to open this up to people that have some questions. Yeah. But one question I have before I open it up to others is, how does Bill Gates come into this picture? Because, I hear things about, people saying that, he's responsible for helping this vaccine get into the people, and it's like depopulation. What do you know about this?
Yeah, so interestingly, full disclosure, my brother worked at Microsoft for many years. He doesn't work there anymore. So, and I was actually funded by the Gates Foundation for about 7 years. I'm currently not funded by the Gates Foundation. They gave me about $6 million for some of our work. So the Gates Foundation has done some really amazing things. They're the largest nonprofit foundation in the world for health-related stuff. So they've provided a lot of funding. But when it comes to this vaccine, it was completely funded by U.S. government, and in some cases UK government, European government, and each of the individual governments like China, Russia, they developed their own version. So he wasn't involved, not in any way, shape, or form. But understand Bill Gates, if you know him, which I know him pretty well, he's a little bit of a fool. He's smart. He's a smart guy, super smart, but he's a little bit of a fool. I think he thinks he can say and do whatever he wants. He can't, and that's kind of a problem for him. He wants the Nobel Prize badly, and he thought he was going to win it by doing world health, by doing, giving money and helping countries with problems. And seriously, the foundation has done some really important things. Childhood education. They've done some super practical things, like, to give you a simple explanation, as the project I was involved with, is they suggested to some places in the developing world that they should use throwaway trash milk cartons. So the plastic milk cartons, the gallon jugs. They said, you can use that to sterilize water. And everybody's like, that's trash. What would I use that for? And so what they do is they put the water in the 1 gallon jug, and they put it in the sun. Most of the areas are equatorial. In other words, a lot of sunlight. So you just use the sun. You put it in the sun for a day in a 1 gallon jug. That water's sterile and drinkable. Whereas if you drink the water otherwise, you get cholera, right, or other types of diarrheal disease. And this kills children. It's the number one killer of children in the developing world, is diarrheal disease. So simple, cheap, doesn't cost anything, right? A gallon throwaway jug. Another thing that they developed was putting the women that wear the scarves, these long scarves in India. They said, yeah, you can sterilize water with that to the point that it's drinkable. And so they tell them, how many layers do you do of the cloth? And then you pour the water through it. And the water has 99% of the bacteria removed from it after just passing through cloth. So super cheap, very practical, common sense approaches with some knowledge. They've done a really good job. But when you talk about things like these high technology vaccines, no, they haven't done. They've gotten lost a lot. They've put money into things a lot of times that haven't been very effective. And I think Bill, as a result, has gotten upset because he doesn't have the chance to win a Nobel. So when COVID happened, he's trying very hard to get involved and take credit. But he actually hasn't done it. So it's like, so people have been very concerned because the way he talked got people thinking he was involved and he was doing stuff and he was playing some sort of games behind the scenes. But in reality, I have not, and I'm involved with all of these people, all of the different companies. We're helping them with different aspects of testing and making sure things are safe and trying to get things to people quickly. We've had a lot of supply chain problems. And he said he was even going to help with that. He was going to help with supply chain, which is something he could do, but he didn't. So I don't know what really happened. I think he may still have a role in developing world for supply chain issues, like factories for producing vaccines, which we need. We have producers, but there are not enough for all of the world, and not consistently, especially if we need boosters in some of these countries that are not really controlling things yet. And it's mostly because they don't have the vaccines at high enough levels yet. U.S. is lucky. We're really super lucky that we have enough of the vaccine and that we can vaccinate everybody. We're stupid in that we can't figure out that we need to be vaccinated, but we still only have about 50% vaccinated, which I don't really understand when we're so lucky. Other countries are not so lucky. And so I think he may have a role there.
Okay, I'm going to open this up because I know, Sonny, you've got some people who have a couple of questions. So go ahead, Sonny.
Yes, Sifu. Well, let me just double check on the people here. We've got a few people online. If you do have a question, raise your hand up so I can get you unmuted there. My wife is on as well. So I know she's full of questions. So I'm going to get her to unmute, please. And so she can ask a question, even though she's going, no, no, no. Cal, can you please unmute yourself?
Okay, so with some of the things going on, I was listening to you talk about that you did get your son and he's only 6 years old. So you feel that once the trials go, because that's something that, you know, of course, with media and everything like that and the information that goes out there, that like definitely, like it's definitely better to get your kids vaccinated than when the time comes for it to be allowed for this.
Yeah, absolutely. And so that's the biggest problem. I'm in Texas, right? So the biggest problem is I've got a governor who's technically my boss, so I have to be careful what I say. I've got a governor that says we can't require masks anywhere, and we're going to go back to school, and we're going to be in person. And my kids, of course, have been learning from home. I don't know, maybe I'm lucky. My kids blossomed working from home. They loved it. They had a blast, and they both. I have a kindergartner, right, and he's just going to first grade. He's reading at like second grade, third grade level already. I mean, they're very, very fast. They're just like, and the third grader is doing middle school level, high school level math now. So this year was not a bad year for us educational. I mean, my son, he was pissed. Okay, he's 20, and was supposed to be at UC Santa Cruz in California, but he was in Texas with me, and I wouldn't let him go out of the house. So you can imagine that wasn't fun. But yeah, so I kept my kids at home, but in August or September, when they start in school, they're going to go back to in person because they're vaccinated. And that was my condition, is once I got them vaccinated, then I would let them go. And they wanted to go. They want to go back to in person, see their friends. Talking by Zoom is pretty good, which they do. They play around with their friends by Zoom, which socialize and all that. I don't quite understand all of this stuff about detrimental to kids' education to be doing by distance. But, you know, I do consider myself an educational professional. So somebody who tells me, well, you're not an educational professional. Well, no, I do. But yes, mostly I've taught college level and medical students. So it's a different level of education, but I don't believe it's been detrimental. So what it comes down to, yes, I would get my kids vaccinated, and I was lucky that I was able to get them into a clinical trial. The clinical trial is Moderna. So they got the Moderna vaccine. They get half the dose. And just based on my background, I was very happy they were getting half the dose. So they're going to do a ramp up. This clinical trial that they're doing right now, they're going to do a ramp up. They started at 50 milligrams, and they're going to go up to 100 milligrams, which is the adult, and they're going to give those doses to children. So with the 6-year-old and the 9, he just turned 9, so I almost said 8. But anyway, he's 9. And the 9-year-old getting, I think, half the dose was perfect. They both had side effects. They both got redness on the arm. And both of my kids, they're part Asian. So I don't know if you are aware, but a lot of times Asian people have very sensitive skin. They respond to mosquito bites, and it's a pain. I don't. I'm lucky. I'm Italian. I don't get that type of response. But they get this huge response. And so the one that has bad skin and always has problems if he gets out in the sun too much or whatever, he didn't have any reaction from the first vaccine at all. But the other one, who has kind of allergies and stuff, he got this rash. It was a weird little rash. He got it on the shot. And he also got it, because we're in a clinical trial, so he had to have blood drawn at the same time. So the arm that had blood drawn, the nurse touched his arm when she drew blood, and he got a reaction there. So I think that was a response to latex. It wasn't even a response to the vaccine. But the second shot, the kid that had no reaction at all had a big red bump all around the vaccine site, and it swelled up, but it was one day. Lasted one day, and then it went down the next day. And he had fever. Both of them had fever on the second dose. The other one had fever on the first dose and the second dose, but not bad. The second dose actually was better for him than the first. He got no rash on the second dose. I don't know why. But anyway, that was it. So that was the 50 milligrams. I don't know. I mean, what they're going to be looking at is the antibody levels in kids. That's what's going to be important. And so that's why drawing the blood is important. We're going to have them go back. It's optional. You don't have to give blood a second time. But I have my kids go back. They don't want to, but I said, it's good for you. Pain is good for you. It's kind of martial arts. Like, yeah, you'll get used to having blood drawn. It's fine. And we bribe them. We say, maybe give you a treat afterwards, whatever treat you want, maybe some ice cream or something. And they're happy. Actually, my kids, they like the money. Give them some money. $1 they're happy with. So we'll go back and have blood drawn, and hopefully we'll find out that their antibody levels are good. But that's the biggest concern, right? 100 milligrams may be better for antibody levels. So whatever they decide is going to have low side effects in kids, because obviously kids, you don't want to have a response, right? Parents freak out if kids have a response. And so doctors know that. And public perception, right? This has been a public perception battle. Everybody looks at this differently. And so we know that in order to get people to take the vaccine and give it to their kids, if they're going to go back to school, which if I was a teacher, I would be really worried about that, right? You have kids go back to school in large groups, and then one of them gets COVID, and that's the one in the 50,000, and they die. And this has happened. We had in Houston just the other day, a kid die 9 years old from COVID, and it was in the course of like 4 days. It was quick, just like that. So I don't want to be a teacher in that environment. I understand kids are less likely to get sick, but if one kid dies on me, I have a heart.
Sonny, you have another question?
Yes, I have John who has a question. John, if you can unmute yourself, that would be terrific, and ask your question.
So first of all,
are you seriously an Aggie?
Well, my stepdad worked for the college, took care of all the livestock for the veterinary program.
Cool.
So
cool.
I know the area.
That's a lot of livestock. You sure you took care of all of it? The campus is huge. It's huge, and it goes all throughout the state. But he was based in College Station?
Yes.
Yeah, that's
and we
the main campus.
We lived out there at the, they call it the Riverside thing now.
Yeah. That area is really nice. That's really close to where I am. I'm in the College of Medicine off 47, right over there.
Okay, cool. So my question is, how does COVID affect like animals?
Oh, that is a very complicated question. And I don't think we know all the answers. So you probably know Texas A&M has a lot of veterinary work. And I actually worked in a vet school for a while. When I was in Nebraska as a faculty member, I worked in the vet college. So I interact a lot with the veterinary people. And it was probably about a month ago, we had the person who looks in livestock and pets. So cats and dogs, but every other animal. She surveyed all these different animals, livestock, and so on. It looked like horses could get it, which was interesting. We were a little bit surprised by that. We saw some in deer. We saw very, very low levels in most rodent species. Cats can definitely get it. She argued that cats cannot transmit, which, I mean, there's no evidence that they can transmit. So in other words, they can infect a person from a cat. But I haven't seen the data on that. We have seen cats infected. Usually we see virus in cats, and they're at measurable levels when the individual in the house is infected. So if you've got somebody in quarantine and they're in quarantine with their cat, they're in close quarters. I mean, this is their comfort animal when they're bedridden. And so it's not surprising they would have virus. And the problem is most of the time there's not very good opportunities for analysis of that transmission to people. We know ferrets can definitely get it. I don't know if you've heard about that. Ferrets and minks definitely get it, and they get sick and they can transmit. Lions and tigers can get it. We have not seen transmission. So you can't get it from a lion or a tiger. I'm not sure you get that close, but you might. Let's see, what else? Dogs, we know they can get it, but they don't get as a measurable virus. In other words, I would 100% believe a dog can't transmit the virus at this point. We have enough data to say they can definitely get it, but I don't think they're giving it to anybody. Cat, I'm less sure about. What else? Are there any other animals you want to know about? You might ask me. It'll trigger something.
Birds?
Birds. Okay, yeah. There have been a few cases of large parrots getting it. There's no evidence that they can transmit yet. But you understand those numbers are so low. And these are people that have parrots, right? And they're transmitting it to their parrots. We know that. But we haven't seen anything go the other way yet for parrots.
Okay, thank you.
Wow. Okay.
Very good answer.
You're welcome. I actually just happened to have gotten the talk on that just like a month ago.
Yeah,
That's not information that a lot of people know. The information I gave you is actually not public.
well, hey, thank you guys. We've had a lot of good sessions, and this is really one of the best. Time is really coming really short for us, and we're going to have to end this. Not that I want to. I could go on talking on forever. Sonny, you got the last talk.
Yes. Well, again, thank you, Jeff, or I should say Dr. Professor Jeffs.
Jeff is fine. In Texas, I haven't been able to get people to call me Jeff. When I was in Hawaii, I don't know if you knew, I worked at the University of Hawaii in Manoa.
Yeah.
I didn't have that problem, I could get people to call me by my first name. And in Nebraska, I could do it, but it was kind of spotty about half the time. In Texas, nobody. I cannot get anybody to call me Jeff. It sucks. I don't know what the problem is.
Well, I can do it because that's what I'm used to, actually.
That's fine with me.
Our
It's fine.
first meeting, and it was terrific. Well, thank you again. I mean, it was so informative, and I know that all the people who are going to listen to the replay on YouTube, make sure if you've learned something, love it, like it, and share this information to all your family and friends and loved ones, because when it comes down to it, I believe that great information like this should be going out rather than all that science fiction. So again, thank you very much, and thank you, Sifu Al, for having this podcast for us. And again, don't forget, guys, to subscribe on the channel so that this way you will be able to get notified when the new or next podcast is coming up. And also don't forget that Sifu Al has a book called Legacy. It's also available on Amazon.com. So make sure you check on that. Otherwise, thank you very much, Sifu Al. Now you've got the final words to say aloha, goodbye, and whatever else you'd like.
Well, thank you, everybody. Let's go ahead and give Professor Science Dr. Jeff Cirillo a really big clap, because it's been really entertaining and informative. Thank you, Jeff. Okay, guys, you know what you have to do. You already got what he said. You take it and use that knowledge. Until then, wish everybody aloha and have a great day. Bye-bye.
Thank you. Thanks for having me.
Aloha.
Bye. Take care.